Hey, GED students. It's GED question of the daytime, and it's not just me that knows how to freak students out with fractions. It's the GED too. So I need you guys to not panic when you see a fraction. Let's remember that our calculator can do the ugly, gross fraction computations that we hate. On the GED, we just have to know how to do the algebra. So let's take a look here. So notice that the directions say solve the equation. I'll just remind you that solving the equation means figuring out what the letter, in this case J, would have to be equal to make this true. And mathematicians do that by isolating the variable, getting the letter alone. So basically, if they say solve the equation, I'm going to work here to get the letter alone. Okay, now I got a lot of numbers to get rid of in order to get this letter alone, but this is what I want to point out to you. Notice that this fraction naturally makes a group up here. I have a J group. I told you in the last video when we talked about solving, we said we work the order of operations backwards, so we should save groupings till last. So I'm going to get rid of this 9. Now, today's the day you've been waiting for your entire math career, the day you got the power to get rid of fractions. The day you got the equal sign, you got the power to do whatever you want. Instead of dealing with that fraction, I could just get rid of it. Quite literally. What do I mean? Well, I mean that a fraction bar literally just means divide. And in algebra, I can get rid of things by doing the opposite. Well, what's the opposite of dividing? Multiply. I'm going to take this entire side and I'm going to multiply by 9. You say, Kate, is that legal? Can I do that? Well, you've got an equation. You can do whatever you want as long as you do it to both sides. I'm going to times the right-hand side by 9 as well. Let's see what happens. On the left-hand side, multiplying and dividing by 9 are opposites. They cancel. That's gone. The only thing I have left is 5j plus 7. I'm going to write it over here on the left since I'm running out of room. And then see, right here, 5j plus 7. That was all I had left. Now, on the right-hand side, that's going to be equivalent. I've got 3 times 9. Well, 3 times 9 is 27. So my new equation is 5j plus 7 is equal to 27. Now it looks a little easier. I got rid of my group. That group is gone. You know, when I got rid of the 9, there was no more grouping. So now I can just take these away in the normal order. I'll take away the guy who's adding first. So I'll subtract 7. Again, this is a change I'm making, so I make it to both the left-hand side and the right-hand side of the equation. On the left-hand side, adding 7 and subtracting 7 cancel, leaving me with just a 5j. And on the right-hand side, 27 minus 7 is 20. I'm almost done, but j is not alone. Right now, I've got to get rid of a 5 in order to get j alone. So this 5 currently is shoved up against j multiplying. I'll do the opposite. I'll divide by 5. Now, literally, I can do whatever I want as long as I do it to both sides. So I'm going to hop across the equal sign and write divide by 5 over there as well. On the left-hand side, multiplying and dividing by 5 cancel, so j is alone just like I wanted. And on the right-hand side, that's the math to do. 20 divided by 5 is 4. And I am done. What number would j have to be in order to make this equation true? J would have to be 4. All right, if you have any questions about this or any other GED math topic, be sure to drop it in the comments and I'll do my best to answer it.